let's look at these. So for number 1, 200 will break down into 100 times 2. So we know the square root of 100, it is 10. So we're going to write it on the outside of the square root. We cannot take the square root of 2, so it has to stay right there on the inside. Okay. For number 2, 50, I could break it down into 25 and 2 or 5 and 10. Is 5 and 10 going to help me? Can I take the square root of 5? Can I take the square root of 10? I cannot. So whenever you're looking to break these down, you're looking for perfect squares, numbers times themselves, right? So you're looking for 4, 9, 16, 25, 36, and so on. So here you're going to break this down into 25 times 2, and we can take the square root of 25. It is 5. It goes on the outside of the square root. We cannot take the square root of the 2, so it stays on the inside. For number 3, square root of 12. Let's see. Hugh, what could I break 12 into? 4 and 3? And so when I take the square root of that, or the parts that I can take the square root of, what will I get, Hugh? Yes, but we do not have to have the plus or minus with it, because here when we're simplifying, the only time we add in the plus or minus is when we're like taking square roots of both sides of the equation. So if you're asked just to simplify, don't put the plus or minus. We're going to see as we do these today, they're usually going to have the plus or minus in front of them because it's going to be in quadratic equation, but we don't need them just for simplifying. Okay? All right, 72. Tyler, what can we break 72 into? Okay, 9 and 8. All right, so if I break it into 9 and 8, what will I get whenever I do that, Tyler? Okay, now, here's the problem. 8 will break down. 8 doesn't seem like it should break down because 8 is a small number, right? But how could I break down 8? 4 and 2. And so if I do this, if I break down 4 and 2, that would be 3 times 2 square root of 2. So I would end up with 6 square root of 2. So watch out on these. Watch out. Do not leave a square root of 8 or a square root of 12 in your answer. So I see a lot of times that kids leave something with a square root of 8 or square root of 12. Those are the biggest ones the biggest mistakes I see because they seem really small, like they won't break down further, but they will. Now, we could have done this more easily if we had picked a bigger number first. 9 and 8 are our multiplication tables that we know and recognize. What else could we have used instead? Aaliyah, 36 and 2 will also give you 72. So if you do that, then square root of 36 is 6. Leave your 2 underneath. So it simplifies a little bit more quickly. But I'm actually very glad that you did 9 and 8, Tyler, because that's something that I see kids do a lot. So. Okay. All right, 243. That's a big number. Leah, what you got? 9 and 27. Okay. So what do you get whenever you do that? 3 and 27 on the inside. Okay. Here's the problem. Will 27 break down? What can I break 27 into? 9 and 3. So I could make that 9 and 3, which means I'd have 3 times 3 square root of 3. If I multiply the 3 times 3 that's on the outside there, I get 9 square root of 3. So, this is correct, but not the quickest way to get there. What could I have used instead, Kayla? 81 times 3, and then I would have went straight to 9 square root of 3. So watch out for those numbers like that that will still break down a little bit further for these. Yes? What I normally do when I'm doing one like 243, because I don't know my multiplication tables up to numbers that big, is I usually, when I'm using my calculator, I usually just, let me get my calculator. I usually just do this. I start with the biggest numbers. So rather than dividing by like 2 or 3 or 4, I'll start, if my calculator will ever come up, I'll start with 243, and so I might start with like 121 to see if that'll go in. 243 divided by 121. See if that'll go. It won't. And then like I'll work my way down. I know 100 won't go into it. It would have to end in double zeros for that. So then I'll try 243 divided by 81. And then that works. So if you start with those bigger numbers and work your way down, you're less likely to choose the 9 or the 4 or something that you could have used a bigger number. The other thing that you can try, like if 9 works, 81 might work, right? Because 81 is 9 times 9. If 4 works, 16 might work because 4 times 4 is 16. So if you see that you get a smaller number that works, then check to see if that bigger number might work. So like if that's another way you can think about it. But you make your life a lot easier if you pick the biggest numbers whenever you simplify those in the beginning. All right, questions? All right, so today you get to learn about something super sophisticated and super high level math. So this is an exciting day. I realize we've been doing a whole lot of just calculating, and we're still going to do a lot of just calculating. But today you get to learn about something that will get you in on a lot of my math jokes that I have back there that you haven't understood yet. Particularly the one with the little guy there, and it says he's got like a speech bubble here, and it says square root of negative 16. All right, it's a pretty good math joke, but if you don't know about the square root of negative 1, then you can't get that math joke. So we can't take the square root of a negative number, because if you try to take the square root of a negative number, you have to have something where a number times itself gives you that number, right? So there is no way we can have a number times itself that gives us negative 24, because a negative times a negative would give us a positive, and a positive times a positive would give us a positive. So you cannot take the square root of a negative number. The problem is sometimes negatives show up. And we have to deal with them. And in some cases, we may actually need to know what those solutions are, because we need to use them later for something else that does turn out to be a real number that applies in a situation. You don't have to write down all of those words, but I do want you to write down this right here. All right, so because we can't deal with negatives under that square root, mathematicians have decided to, instead of putting the negative under the square root, we're going to call the square root of negative 1 I. Okay? We're just going to replace it with the little cursive looking letter I. Right? So when we see that I, it means square root of negative 1. And this way, maybe we won't have to deal with negatives underneath the square root. Now, when I was in college, I took a whole class on just complex numbers, which is what we call things with I's. And at the end of this whole class on complex numbers, I still did not get into like really detailed applications of this. So this stuff can be used, they tell me, for a lot of really cool stuff. They tell me that like whenever they're like routing cell phone calls and stuff, the networks that do all of that crazy stuff that I really don't understand, it just seems like magic, that the I comes into play there for the formulas that do that sort of stuff. There's some other things where this can apply, but I will tell you, when you get to the applications of I, you're looking at some higher level math, some stuff that's going to get pretty intricate. So we are not going to really see applications of that in Math 2 in the 10th grade. But the state says that we still need to consider this because they want us to know what happens when we have that negative under the square root and how to deal with it. So we're on the verge of something like really crazy great, but we're not quite get to the applications because it's a little advanced. But it is something we need to know how to deal with. So it's really, I think, pretty easy. And I love math that sounds really hard and crazy, but is really not that difficult. Because then you can like impress people with it. Trig is my other favorite thing to teach. That we'll do that in this class too, because trigonometry just sounds really like insanely difficult, but it's really not. So I like to talk about it. So right here, when we have the square root of 24, this is what we're going to do. That negative right there, we're just going to make it a negative 1 times. And then 24, I'm going to break down just like I would if I was doing the first 5 problems that we had here. So 24, Philip, how could I break down 24? 12 and 2, but can I take the square root of 2 or 12? No. So what else? Adam? 4 and 6, right? So 4 and 6. Alright, so I'm going to do this just like I've been doing the other problems. Except, when I take the square root of negative 1, I'm going to call it I. So I'm going to take the square root of negative 1. It is going to be I. It's going to go on the outside. I'm going to take the square root of 4. It is 2. Typically, we put the 2 in front of the I. Technically, it could go behind, but you don't ever see it written like that. And then the 6, can we take the square root? No. So we just leave it right here. Okay, so the next problem, we've got the square root of negative 700. So Jaden, how could I break down negative 700? Not 7 and 10. You've already taken the square root, right? 7 and 100. And since it's negative, I have to have that negative 1 out there, right? So I'll have negative 1 times 7 times 100. So if I walk through this, Jaden, what is the square root of negative 1? We can't deal with it, so what do we just call it? We call it I. Right? And I is always on the outside of the square root. What about 7? Can I take the square root of 7? Nope. So it stays on the inside. And then what about 100? What's the square root of 100, Jaden? What? 10. Good. So that goes out here. Alright, so we get 10I square root of 7. Alright. Let's see, Stephanie, what about number 8? Negative 140. What could I break that down into? Okay. So we'll start testing if we're not sure. Like if we start testing, I know there's a lot of numbers that won't go into it. Like, I know 100 won't go into it. 81 is too big. Let's see, after that, we would have 49. I'm pretty sure 49 won't go into it. Then we could go 36. Maybe 36 might work. Nope. 25 is not going to work because that'd be 150. So then we're probably going to get down to the small numbers. Oops. 4 work. 4 works. If 4 works, check 16. 16 does not work. Okay, so 4 and 35. Alright, so we've got our -1, our 4, and our 35. Okay, so Stephanie, whenever I do this, what's our square root of -1? I. What about the square root of 4? It is 2. What about 35? We can't do it, so it stays underneath the square root. Okay. Number 9, we've got 48. Let's see, Jalen, 48. How can we break down 48? We could, but we should have red lights flashing and alarms going off whenever you hear one of those numbers right there. 12, we don't want to leave underneath the square root, right? So that tells me there's something bigger that might go. So if 4 works, try 16. Will 16 go into 48? It'll 3. So that will be a little bit easier for us to deal with. And so it's really, I still sometimes leave 8 or 12 in my answers, but like try to picture red lights flashing, alarms going off, the room getting dark whenever you see an 8 or a 12 in one of those, because you don't want to leave those in your answer, and you can make it a lot easier by using a bigger number. So, so for this, Jalen, what's the square root of -1? I. What's the square root of 16? 4. What about 3? Can't do it. Stays underneath the square root. So we get 4i squared of 3. So if we go back to my joke back there, where I've got this guy and this guy, and he's telling him square root of -16, and it says mathematical insults. What's he calling him? 4i. Square root of 16 is 4. The negative is an I. So he's calling him 4i's because he's got on glasses. So, get you in on some good math jokes if you know what square root of -1 is. Yeah. So, please do not pick on Abril or Hugh or me. Anybody else. That. So, also back there where I've got that T-shirt I wear a lot of times too that says square root of -1 heart math. I love math because square root of -1 is I. But it can get really complex. These are actually called complex numbers, and it does get very complex at some point. But right now, basically, it's exactly what we did before, except for everything's got an I with it, right? So it's pretty simple to deal with. At the level we're going to look at, it's not going to get all that difficult. I always hesitate to tell students this, but we call that I right there the imaginary number. I typically don't tell kids that at the beginning, because as soon as you hear that something is imaginary, you want to ask, why in the world do I ever need to learn about something that's not even real? So you just want to give up right then. But it's these are called imaginary numbers. They seem really difficult, but they're not at the level we're looking at right now. They're not that bad, which is math I really like because then you seem really smart. You go take your parents these worksheets and you've got like all these square roots and i's and plus or minuses places. It looks like, sometimes like in movies they'll flash up like crazy math formulas on the screen when somebody's thinking. It looks like that sort of stuff. So I always like scary looking math. Alright, write down these next few. We've got to simplify these. Alright, back to this. So we know, we just said that we're going to let I equal the square root of negative 1. We have established, since we don't like negatives under the square roots, we're just going to call it I so we can deal with it. So, if I have I squared, then that means that's the square root of negative 1 squared. Correct? Alright, so what is that? What is the square root of negative 1 squared? It's not going to just be 1. It's not going to have an I in it. What do square roots and squares do? They cancel each other out. So if they cancel each other out, then I'm just left with negative 1. There. So I squared equals negative 1. So I squared is actually not an imaginary number. I squared doesn't have an I in it at all. It equals negative 1. Okay? What about number 10 is I to the third? Okay? So let's think about what I to the third means. That means I times I times I. Well, these two i's right here, I could put them together. I could make that I squared times I, if I wanted, right? What is I squared? It's negative 1, right? We just found that in the last thing. So that would be negative 1 times I. So I to the third is going to equal negative I. You can go ahead and put that for your answer. Okay, so this next problem has an I to the fourth in it. So let's keep on. I to the fourth. That's going to be I times I times I times I. So that is I squared times I squared. And what is I squared? Negative 1 times negative 1. And what do you get when you do negative 1 times negative 1? Positive 1. So I to the fourth is positive 1. Alright? Now, you don't have to do an I to the fifth on what we've got here, but let me just keep going to show you something here. So let me just write this. I to the first, obviously, is just I. Alright? I squared is negative 1. I to the third is negative I. And then I to the fourth is 1. Okay? So, if I want I to the fifth, right, that means I've got to do I times I times I times I times I. Well, I could put those first four together. So that'd be I to the fourth times I. And I to the fourth, would we just find that was 1, right? 1 times I. So I to the fifth is I. What's I to the sixth going to be? It's going to be negative 1. What about I to the seventh? Negative I. I to the fourth, I to the eighth, 1. It just keeps repeating itself over and over and over again. I don't think we have to do these problems. I know Coach Wood's class was doing it in Math 3 the other day when I had to cover his class. But we can do a problem like I to the 243rd really easily because it just repeats the pattern over and over and over again. I think we get to stick with the pretty simple ones as far as we're concerned here. But if we go back to 11, so if I've got 3I squared times 5I to the fourth, then Zoe, what is I squared? It is negative 1, so I could replace it with a negative 1. And then I'd have 5 times, Zoe, what's I to the fourth? It's just 1, right? So what I've really got here is negative 3 times 5. And I get negative 15. So that expression doesn't even have an I in the answer. Okay, same thing's going to happen on number 12. Trace, what is I squared? Negative 1. And what is I to the fourth? 1. And what is negative 1 divided by 1? Just negative 1. Yep. So your answer is just negative 1 for that. So on a lot of the problems, specifically when you have even exponents, the i's will just go away on a problem like these. Okay. All right. So here is the last thing that we're going to do, and we're going to do some quadratic formula with these, except for we're not just going to write no real answers. We're actually going to simplify our answer and use an I in our answer. No real answers is correct. Whenever you write no real answers, there are not any real answers when you have a negative under that square root. But at this level, we have to also give the complex solution sometimes. So whenever you're given a problem like this, you might have no real answers as your answer, but also that might not be there. They might have complex solutions. So if we have 2x minus 5, 2x squared minus 5x plus 7 equals 0, everything's already on one side. We just need to do quadratic formula. So we'll have x equals opposite of b plus or minus square root b squared minus 4ac all over 2a here. And so when we do this, we're going to get 5 plus or minus. Somebody tell me what we get under that square root. Negative 31. All over 4. And this one's not so bad because will 31 break down? 31's a prime number. Nothing will go into 31. So our answer here, we don't really have to break down anything except for we don't want to leave that negative under the square root. We want to take that negative 1 and write it outside as I square root of 31 all over 4. Okay, so technically this also is no real answers. These are not real answers because they have an I in the answer. It's a complex answer. But in a lot of cases, you're going to see this instead of no real answers or no real solutions. Be really careful with placement here. Notice when you're breaking this right here down, it goes right here after the plus or minus. Don't put your I over here with a 5. It doesn't go there. Okay. All right, let's do another one that'll simplify some. Now technically, I could divide everything by 6 here, and I encourage you to do that whenever you're solving this problem. But I want you to see how to simplify. I want you to see how to simplify these. So we're not going to divide by 6 first here, even though we could. And you make me some good problems where you still have to simplify, even though it's not a GCF, but they're hard to come up with. Alright, so if we do quadratic formula here, we're going to have negative 12 plus or minus square root 12 squared minus 4 times 6 times 24 all over 2 times 6. And so that is going to give us negative 12 plus or minus, what are you guys getting underneath that square root? Negative 432. Somebody else check that for me. 432. Okay, all over 12. Okay, so right here, whenever you see numbers this big and even numbers underneath the square root, it's probably going to reduce. So, 432, first thing you need to check is just make sure you can't take the square root of 432. You cannot. So 432, what do you think will go into 432? Is 12 going to help us? 36? Okay, 36 and 12, that tells me there's something bigger. Because if there's a 12, it could be something bigger. What? 4. And, can I take the square root of 108 though? I cannot. So that would actually be smaller. What have you got over here? 144? And 3. So 144 and 3 is our biggest number that we can use. So practice, finding that biggest number. So negative 12 plus or minus, and I'm going to do this up here. So it's going to be negative 1 times 144 times 3. The square root of negative 1 is I. The square root of 144 is 12. And 3 you cannot take the square root of. So you're going to have 12I square root of 3 over 12. Now, whenever we reduce this, remember, you have to be able to divide all 3 of these numbers by something in order to reduce. So don't just cross out those 12s. It's going to be negative 1 plus or minus. You could put the 1I square root of 3 if you want, but the 1's unnecessary, so I'm just going to put I square root of 3. And you could put all over 1 if you want, but that 1 is also unnecessary, so I'm just going to leave the answer like this. Okay, questions? All right, here's one more. Let's start our last one. All right, now this time, let's just go ahead. Let's divide by a greatest common factor. What number could I divide all those by? 4? 4 go into 42? No. 2. So we could divide everything by 2. Alright, so we'll get 6x minus 21 equals 4x squared. And then move everything to one side. Or you can move everything to one side first. Doesn't matter. So you got 0 equals 4x squared minus 6x plus 21. could see if that would factor. Usually on a problem like that, even like probably it's not going to, because I'm wanting you to work on complex numbers right now. But even if you didn't know, I usually use quadratic formula on one like this, because by the time you try to guess and check and factor that, it might take forever, and it might still end up not working, and you might have to use quadratic formula anyway. So this is one. Go ahead and use quadratic formula. So x equals 6 plus or minus the square root of 6 squared minus 4 times 21 all over 2 times 4. And so for that, what do we get? Negative what? 300? Somebody else got the same thing somewhere? Okay. Alright, all over 8. So here we've got 6 plus or minus the square root of negative 300 over 8. Square root of negative 300 will break down. So, David, how could I break down the square root of negative 300? Not 10 and 3, but 103, yeah. So we do 103, and then we've still got that negative 1 also, right? So the square root of 100 is 10. 3 stays underneath. The negative comes out here as a 9. All right. So this is going to be x equals 6 plus or minus 10I squared root of 3 all over 8. Okay, questions there? We can. So, and you need to. So 6, 10, and 8. Now this, on the last problem, they were all 12. So they just kind of divided away, right? And became ones. But on this one, what number could I divide all 3 of those by, Kayla? 2. So I'm going to divide this by 2, and this by 2, and this by 2. You do not divide. It will need to be simplified all the way to get full credit for it. So if you get here, then you're going to get some partial credit if it is one that I'm giving partial credit on. But to get full credit, you've got to get all the way to the fully simplified answer. So 3 plus or minus 4I squared root of 3. 5, sorry. 5I squared root of 3 all over 4. All right. So you've got to simplify it all the way to get full credit for it on those. And then there might be some where they're like multiple choice, so you would have to do that as well. Now, as far as, well, actually for these, you can't get a decimal answer because you got a negative under the square root. So there's no way you're going to get a decimal for this. So on these, you need these two are equivalent. If it didn't have the I, the decimal would be the same for both of those. But if they're asking for exact answers, they're going to want it simplified all the way down. Okay, and then this is our answer. Notice here, I didn't touch the square root of 3. By dividing that 10 by 2, I'm dividing that whole term by 2, so I don't have to touch the square root of 3 right there. So don't mess with it. Just these 3 numbers right here are the ones that have to reduce. Okay? Questions? All right.